So the key here is that once you draw the table, you know how many unknowns you have. And that tells you how many equations you have. So you definitely need to get 4 equations. And how could you get those equations? Up till now we said, well, we could get 2 equations from each each two-dimensional body, so let's draw 2 free body diagrams. But in this case, it may have been easier to take some of the forces in the y from this free body diagram, and then be done with it. Do some of the forces in the x from this, what do we solve? NB1. Some of the forces in the y from this free body diagram, you get this. Some of the forces in
we wouldn't have to leave
y.
free body diagram A once we have free body diagram AB though. We would just stay on A because we can get from.
Say that again? I didn't.
So free body diagram AB.
Yeah.
We get that NA equals NB2.
Right. So we get
So
NB1.
Then we can stay on free body diagram A after we get our.
Yeah. So we
floor
get
normal.
this from 1. I mean, there's many ways that we could solve it, but let's try to figure out the quickest. One is finding NB1 first. Then going here, if you have NB1, then I would do some of the forces in the y and get NAB that way. Or you could have done some of the forces here to get the y component NAB. So either one of these would have given you NAB. And then some of the forces in the x would give you NA here, and some of the forces in the x here would give you NB2. Danny?
The small mass is not pushing on the center of mass of the large mass, which would make me think that not all of its weight is contributing to NB1. But by that
The weight of which one? The weight of A.
Right. The weight of A
The weight of A
is not over the center of mass of the weight of B.
on top of, you mean?
Yes.
Okay. So only part of the weight is only part of the weight of A is contributing to the normal between A and B.
Right.
Which means only part of the weight.
That's not what I'm talking about.
Oh,
I'm talking about the normal between B and the ground. By that statement,
this one.
yes, by that statement, it's saying that the weight of A and the weight of B are equal to the normal of B with the ground.
The normal of B1 is equal to the weight of A plus the weight of B. That's correct.
Right. But it makes sense to me that not all of the weight of A is contributing to that normal force because it's not over center of mass of B.
It's just the y component of weight A, not the full weight. It's only partial weight.
No, he's not, but the weight is going in the y direction. So you're saying when you look at this, you think, or look at that, you don't think the whole weight of A is contributing to the weight of B. But it is.
It is?
Yeah. If you do this, it is
You say so.
contributing. What?
I said I believe you. You said
Oh.
so.
It doesn't just have to be on top, it's the sum of the forces. Okay, in this free body diagram, could I have just drawn all this as one dot and drawn NA, WA, WB, NB1, and NB2?
Yeah.
I could have drawn them all as a dot. I could have done it. Could I have done this? Would this free body diagram, would this have been correct?
No.
No. Why not?
Not
Why
all
not?
concurrent forces.
Say it again?
Not all concurrent forces.
The forces are not concurrent. Right? If this wall wasn't here, this could actually rotate, couldn't it? Right? If this wall wasn't here, these things could rotate. This could fall down from it. All these forces are not acting on the same point. They're not all concurrent. So you cannot do this. You can only take a body and make it a dot on one point if all the forces are concurrent. Yes?
So should you leave the forces, the internal forces out completely? Like if you did
Yeah.
those as dots instead of bodies, then what would that, like, do you need to do them as the?
You have to do it as bodies, you can't do it as dots. You can't do this, because it makes it look like they're not even touching.
Yeah,
You have to draw them as a body.
instead of just doing like the forces and then the cancel or something. It's to
You
do
don't
it.
want to go and do this, NAB and NBA. You don't want to start doing that, because then you're really back to what you have here, and then you didn't even need that. If you break these two apart, you're really back to these two free body diagrams. The reason for putting the bodies together and analyzing them is so that the internal force is now something you don't have to analyze. Okay, so what I would suggest, remember when you're doing the tech, remember what did I say about the exam? I'm going to make sure that I'm picking problems from the textbook, right? And why am I doing that? Because I'm trying to get you to do more problems than just the homework. If you just do the homework, you're probably not going to finish the test. You have to practice. You have to do a lot of problems. And every problem has some little thing in it. Okay? So what I would do is I would set up each of the problems. Now these are all, look at all these problems, let's see. Here, how about this one? We have a block. What force is in this tension? The weight of the block. What force is in here? The weight of the block. This we can find, but actually I think this is a maximum problem. So they're telling you 100 pounds. But go through all these and come and see me, and I can help you set them up to make sure that you're comfortable. And especially do the example problems, because they're showing you exactly how to solve it. So try to do it. You have the solutions right here. These are all 3D. Think about how many bodies you're analyzing. Notice it's all concurrent, right? All these forces, they're all concurrent, all acting at the same, all acting at the same point. That's typically the case with 3Ds. Okay. So we still have this week. Ben's in the STEM Center today, Tuesday, and on Wednesday. I'm there on Thursday, and then your exam is on Tuesday. You have to
If we were going to solve this problem completely, how would we use the diameters of the spheres?
Then you'd have to do the geometry, because you need to know what that angle is. These distances will give you the angle. Okay. And we can do that, but I'd rather not spend time doing it now. Okay, so I passed the sheet of paper out to everyone, and it looks like this. There should be some extras. Pass them back. Pass them back. What? Oh. Okay, I'm passing around attendance. Okay, so we're going to go back to doing moment problems. Yeah, it's in the packet, and this is one we did the other day. So you already have it. Okay, so how are we calculating moments? We're using the right-hand rule, right? Right-hand rule. So how do we find the moment or the torque around something, we multiply the magnitude of the force times the magnitude of the perpendicular distance. And then how do we determine whether it's positive or negative? Using the right hand. So let's just do these over. We did them the other day. So we're looking at the moment about point A. So it's, where are we? Sit, Lolly? So in order to calculate the moment about A due to the 100, it's what?
Isn't it 100 times 5?
100 times the perpendicular distance, and is it positive or negative? So everybody, put your fingers in the direction of force. Everybody, fingers in the direction of force. Palm goes towards the point I'm trying to find the moment about. Is it positive or negative?
Positive.
Positive. I'm not going to do all the numbers and the units because we already did this problem. How about B? Spencer?
It's gonna be
100 times
10.
10. Positive or negative?
Negative.
Everyone, fingers in the direction of the force. Palm towards the point I'm going to find a moment about. I got a negative. Does it make sense physically? Look up here. This force is going to cause this thing to spin in this direction. Looking at this point, this force is going to cause the spin in this direction. Okay, how about number 2? Next, Brandon. Trying to find the moment about A.
150 times 7,
150 times 7. Why 7?
because that's perpendicular distance.
That's the perpendicular distance. It should be the perpendicular distance between the force and the point I'm trying to find the moment about. Positive or negative? Fingers go in the direction of force. Palm goes towards A. What did you get?
Positive.
Positive. Okay, next. You got
150 times 7.
times 7 again. I'm trying to find it about the moment, about point B. Positive or negative?
Positive.
Positive. Matt, moment about C?
0,
Why?
because there is no perpendicular distance.
There's no perpendicular distance, there's no lever arm, that's all. This force could only create what motion about C?
Translation.
Only translational, but it could cause the whole thing to rotate. Okay, so now we're up to this problem. We're up to number 3. The moment is the absolute value of the force times the absolute value of the perpendicular distance. In this problem, though, can you right off the bat figure out the perpendicular distance between the force and point A? Can you find this perpendicular distance? If you're a geometry whiz, maybe you can figure it out. Can you think of another way of figuring out the moment that this force causes about point A without trying to find this perpendicular distance? What could I do to the force?
Take a
Put in X and Y.
cosine of
Y cosine, what are you trying to do? When you take a force and multiply it by its cosine, what are you doing?
Break it up into X and Y
You're
components.
breaking it up into components. So we're going to break this up into components. So Fy, the y component, is 100 times the cosine of 50 degrees. Let's get some numbers.
Did you mean to say 30 degrees or 50 degrees? Or is it 60?
Oh, it's 60, sorry, because this is 30 right here, right? So this right here is, yeah, it's
Yeah.
60, thanks. What did you get? What did it come out to be? Cosine of 60, isn't it 0.866? So does it come out to be 50?
Mhm.
50 pounds here. And then here's Fx. And Fx is equal to F times the cosine of 30, which turns out to be 86.6 pounds. So what we did is we took this force and we calculated what its y component is and what its x component is. Now, do we know the perpendicular distance between each of those forces to point A? Okay, where are we? We're marking.
Do 100 times.
Say it again?
100 times.
Well, let's use these numbers since we know what these are now.
Okay, 50 times, or
So 50?
86.6.
50 times, what's the perpendicular distance between Fy and point A?
7.
Try again. Here's the force. This is the line of action of the force. What's the perpendicular distance between it and A?
5.
5. And is it positive or negative? Everyone, fingers go in the direction of Fy. Palm goes towards A. Positive or negative?
Positive.
And Marky, how about the other? So Fx is 86.6 times, what's its perpendicular distance to point A? 7. And is it positive or negative? Everyone, fingers go in the direction of Fx. Palm goes towards A. It's positive. And what does that number come out to be? 856.2, and the units are pound to inch or inch pound? Inch pound. So in the two problems above, the forces were given in x and y, so it was very easy to find what the perpendicular distance was. In this problem, the force is off at an angle from the x and y axis. So rather than trying to find the perpendicular distance, we broke the force into x and y and then did each force independently to find out what moment is created. So for MV, let's do Fx, we'll do 50. 50 times, so Tim, I'm up to you. So we're looking at now point B. What is the perpendicular distance from Fy to B? 10. Does it create a positive or a negative moment? Try again. Fingers go in the direction of the force. Palm goes towards B. It's causing it to spin that way, right? When Fy is going up and we're looking at A, it's causing A to go this way. But if I'm looking at B where the spin is going to occur, it's causing a spin going that way. It's negative. And Tim, and then we have the 86.6, and what's the perpendicular distance between Fx and B?
7 inches.
Great. Is it positive or negative? Positive. Fingers go in the direction of force, palm goes down to B, and it turns out to be 106.2 inch pound. And both these turn out to be positive. And then how, Tim, do you want to just do the last one? Moment about C?
0.
Why?
Because there's no perpendicular distance.
No perpendicular distance, it can't create a moment. So now I have a question for you. What is the perpendicular distance from force to point A? I want to know what is the perpendicular distance from the force to point A. So here is our force. Had we known the perpendicular distance, we would have been able to find the moment. But to make it easier, we broke it up into x and y forces and found the moment. I now want to know what that perpendicular distance is. So talk to the person next to you. How would you calculate the perpendicular distance?
What is it? One.